In this video, we're going to discuss finite differences with polynomials. So what this allows you to do is to determine the degree of a polynomial. And so what's true about polynomials is a polynomial with degree n will have nth order differences that are constant and non-zero between equally spaced x values. So we're going to look at that. That's called finite differences. Okay, so first you must have a good certain amount of points to be able to figure this out. So if you had like a 10th degree polynomial, you would need a whole lot more points. But what this means is, okay, we're going to go through and I'm going to show you what finite differences are. So the first thing is, I'm going to write, you need a table of values. You need points to do this, and you need points that are equally spaced x values. So look, these are all 1 unit from each other. So we're going to be looking for what's called constant differences between equally spaced inputs. So I have f of 2, right? F of 2 is 10. So I have 10. F of 3 is 13. So I'm going to write 13. F of 4 is 16. F of 5 is 19. F of 6 is 22. F of 7 is 25. Okay? So, order differences is going to be the differences in the y values. So I always start on the right-hand side, okay? And it has to be, you have to be calculating them between equally spaced x values. Otherwise, this constant non-zero doesn't matter. So notice, they're all 1 unit from each other, so I can do this. So 25 minus 22 is 3. So the difference, okay, this is the first set of differences, okay? 25 minus 22 is 3. 22 minus 19 is 3. 19 minus 16 is 3. 16 minus 13 is 3. 13 minus 10 is 3. Notice, all of the differences between equally spaced x values is constant and non-zero. It's 3, okay? And this is the first order of differences. So, because when you subtracted the outputs and you got constant values just once through, that means that this table represents a first degree polynomial. That means this is linear. Okay, notice it, as x increases by 1, your outputs continually increase by 1. So you catch it at the first order. So this is a first order difference. That means this table represents a first degree polynomial. So let's do another. So here's our next example. Okay, we have a table of values. First thing we have to check, if we're going to try and figure out what its degree is from a table of values, we have to make sure we have equally spaced x values. Otherwise, we can't look for these nth order differences because we're only looking for them when we have equally spaced x values. So let's check. Okay, they're all 5 units from each other, so we can now apply our finite differences. So we're going to write down g of -5, g of 0, g of 5, g of 10, g of 15, and g of 20. Okay, so that's going to be, I like to write everything out so that I can show my work and not make a silly mistake. And remember, you either have to work, I worked from right to left and I subtracted, or you work from left to right and you subtract. But you should really subtract from the largest x value going down. So we're going to get our first, when I go through and I do this, okay? This is your first order of differences, okay? When we go through and do it once. So 450 minus 152.5 is 302.5. Now, 152.5 minus 25 is 127.5. 25 minus -2.5 is 27.5. Now the next difference, -2.5 minus -5 is 2.5. -5 minus -57.5 is 52.5. So this line is called our first order of finite differences, okay? Are these all the same exact value? No. So is this linear? No. So now we're going to get what's called the second order of differences. So now we're going to subtract these differences. So 302.5 minus 127.5 puts us at 175. 127.5 minus 27.5 puts us at 100. Now, what's 27.5 minus 2.5? 25. Now, what's 2.5 minus 52.5? Negative 50. Are these, this is your second order differences, are these constant and non-zero? Meaning, are they the same exact value and as long as it's not zero? No. What this means is, this is not a second degree polynomial. So, that means that this is not going to be a quadratic. So, keep checking. If you know that this is a polynomial, okay, if this wasn't a polynomials table, then this doesn't mean anything because this is specifically finding the degree of a polynomial. So, 175 minus 100, 75, 100 minus 25, 75, 25 minus negative 50, 75. This is the third order of differences. Are these all the same and not zero? Yes. That means that this polynomial, okay, represents, this table of values represents a third degree polynomial. Now, once you can determine that this is what degree polynomial it is, and because you have a table of values, this actually allows you to write the equation of the polynomial, but because of the situation that we're in right now, not everyone has a graphing calculator. We're not going to do that, but you are responsible for knowing, given a table and knowing that it's a polynomial, finding its degree. And the way you do that is through finite differences. So if when you have equally spaced x values, if you're getting that the differences are constant in the nth order, so in the third order, that means it's a third degree. Okay? If it was constant in the fifth order, then it would be a fifth degree polynomial.